तीन सिर के होकर के प्रकट हुए, मतलब तीनों का अंत है समाविष्ट था। ब्रह्मा विष्णु महेश तीनों का ही अंत है समाहित था, इसलिए तीन सिर के होकर के वो प्रकट हुए। अब इसलिए नाम का संस्था तीन सिर के होने से से नंबर पे करता कोई बचपन से ही इन्होंने हर बार त्याग दिया था और जाकर के सही पर्वत की गुफा में बंदरा में भगवान दत्तात्रेय रहने लगे।
Let's wait for a few more minutes in case more people are joining and then we'll start. I hope you can all hear me fine. I think today there is no internet problem. Just give a thumbs up or something if you can hear me. Yeah, okay. Okay. Thanks. Okay, I think we can start the class and people can join as they come. So let me just turn on my camera. Okay, so hello everyone. Hope you can see me. Oh, okay. One sec. There's some issue with my camera. So yes, so hello everybody. Hope you can see me and hear me fine. Can someone tell me if the connection is okay today? Just write in the chat if connection is fine today because last week there was some issues with the connection. Okay, if there is any issue with the connection at any point, please let me know. I will just share my screen. Okay, sorry, this is week 4. Can you all see my screen? Is my screen visible?
Yes, ma'am.
Okay, fine. Thanks. Okay, so hello everyone. Welcome to week 4 of this problem solving session. So, in case someone is joining for the first time, my name is Zenia. I am a PhD student. I am an astrophysics PhD student at Indian Institute of Science, and I've been conducting these sessions on every Monday from 6 to 8. Apart from me, there are, I think, two more PMRF TAs who will be, and our job is to basically solve the problems for you. Okay, so these will be some assignment questions and some programs which will be helping you to solve similar questions in your assignment. So not exactly your assignment problems because that you have to try on yourself, but something related so that it becomes easier for you to understand. And of course, as I have been saying every week, this is my email ID, and if you have any doubts or any clarifications that you need, I will prefer if you mail me on my email ID. And also, if you want me to explain some particular program or some particular concept in detail for a particular week, you can always mail me just before the class. I mean, not just before the class, but few days before the class, so that when I prepare the slides, I can prepare it according to your doubts. Okay, so this is basically a live session because the videos that you watch of NPTEL are the pre-recorded ones, whereas here you are interacting with me live, so you can clear your doubts easily. Okay, it's an opportunity for you to interact and clear your doubts more. Anyway, this is my website where I maintain all the links. So all the slides and recordings are also put on YouTube, and the slides are in Google Drive along with the programs for this course. So I hope that you have been able to access all that, and I will share this link once more towards the end of the class. Okay. So this week, this is week 4 lectures that we'll be discussing. So this was mostly about, matrix operation. So one way in which you were finding a way to manipulate matrices was through construction of magic squares. And then you found out how to code up some simple games like the double guessing game and the guess the movie game. And, these give you an idea about how you can use user input or you can generate output in a creative way. Because till now we have only done some basic functions like, getting an input and then printing something for a very functional case. But here, you see how to also construct some fun things like, having games or, constructing some patterns and so on. These kinds of exercises are important because, as I said before, when it comes to programming, the most important thing is logic. And when you try to, for example, construct a magic square that follows a specific pattern, and identifying patterns is a very big part of programming, because as I told you before, like, computer does not think on its own. Computer can do tasks repetitively very fast, but we need to give some funda for how the computer should proceed, right? So when we are able to take a program or take a take a problem statement and find out what is the pattern, underlying pattern behind it, that is only what becomes your algorithm. That is only what helps you to create program. So, many of you kept asking me in the first few classes about how to build programming logic. There is no shortcut. You have to keep making programs. And I think if you take programs which are, fun to you, or you come up with a problem in your own life and try to find what is the funda or what is the program, what is the pattern that I can use to make this simpler, right? If I want to print number from 1 to 100, if I'm going to sit and give 100 print statements, there is not much use of me using a computer. If I'm using a computer, it should be because I can make it do much more efficiently. That's why I use, for example, a loop. So that is basically how you do. So magic square is, for example, such a concept where, constructing a magic square for, say, a 3 by 3 magic square is very easy, right? We can sit with some pen and paper, and in some time, maybe in 10-15 minutes, if we try hard, we can get it. But suppose you tell me to construct magic square of order 20, then it's really difficult. I have to go through so many permutations and combinations, and then only I can do it, right? Whereas a computer can very quickly do it once we find the funda. So that's what you do in programming, is you understand first the 3 by 3 magic square, then you can apply that concept to the 20 by 20 magic square. So you start with a basic case and you try to find the pattern there, so that tomorrow if someone wants a 50 by 50 magic square for whatever reason, you are able to apply the same idea to the bigger case. Okay, so a lot of times what happens is, when we do programming, we try to go for the most difficult cases first, and then we, get stuck, we get frustrated. But what we have to do is, we have to keep breaking the problem into different parts. So, first make it work for n is equal to 1, then make it work for n is equal to 2. Like that, you have to keep building your cases, and then you have to check if at every stage is it still working. Maybe n is equal to 2 it works, but n is equal to 3 doesn't work. Why is that? Because we have to add something extra. So this is how you approach programming logic. The reason I'm saying all this is because in first few classes, many of you are asking how to, get into programming, how to get into logic. So this is how you do it. Always, before you write a program, always have a pen and paper also, so that you can work out, right? If I give a is equal to 1, so that's why these assignment problems are very useful, where you get a piece of code, and essentially you are having to predict what the code does. That's what we do when we program, right? We write a program and we are trying to predict if the code is trying to do what we want, and then if it doesn't, we have to go back and do error shooting. This is the idea behind this week's lectures, and why, doing these kinds of problems is very important, because recognizing patterns is very important, I would say. So again, I'm going back to the slide which I'm showing in every class, which is that always have these set of good coding practices with you, because to you will not look at, you will understand the program very well now, but after 6 months, if you open the same file, you should be able to understand it. And not only that, tomorrow if you give me, you give your friend the same file, he should be able to, or she should be able to understand it. So always try to choose some meaningful variable names, function names, file names, use comments, use indentation, and at a higher level also try to create some readme files. So this is just a reminder every time, because every time you write code, you should try to think in this fashion. So this is just about lists, data types. I'm just keeping all the stuff that we have used before, because again, programming is something that builds, right? Just because we did data types in the first class doesn't mean that after that we don't need data types. Now we need lists and data types and patterns. So every time it keeps building. It's a cumulative process. So we already saw about how to use lists, which are basically arrays of variables under a single name, and how to index them. We did a lot of list operations last time. Then we looked at data types in the first class. We also looked at, yeah, multiple kinds of data types, operators. These are all very important, because this is how you will be establishing the relationship between two variables or something like that, right? And this is the program for Magic Square, which you already saw, which is essentially, if no, someone has forgotten, Magic Square was an arrangement of n squared numbers from 1 to n squared. So if it's a 3 by 3 Magic Square, that will have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1 to 9. And the way that you arrange the numbers is that every sum, row, column, and diagonal should have the magic constant. And this magic constant has a value, and there are some mathematical ways in which you can arrange the numbers. So you start by putting 1 in some specific position, then you move some way, and then you put 2, and then you move another way and you put 3, so that you're balancing out the sum in the final way, right? You like So along with 1, if you put 2 and 3, then it's going to be a very small sum, right? Along with 1, we should put some big number. Along with 2, we should put a slightly less big number. So the overall the sum will be the same. So this is the funda, and I'm just going little fast because I think you have already seen these things. Does anyone have any doubt in these things? Actually, I can stop for a second if anyone has any doubt. Okay, if you have any doubts at any point, please like stop me. As I said before, the reason we are having these classes along with your recorded lectures is so that you can have some interactive session where you actually clear your doubts. Okay, so this is the idea behind it. So please, if you have any doubts, please feel free to stop me at any point. Okay. Okay, cool. So my point is that this is one example why magic square particularly, what is the, you might ask what is the practical use of it. But as I said, not everything has to be practical. And also like uh, these kinds of like recognizing how to arrange the numbers to follow this pattern is very useful. And tomorrow you might have a problem where the pattern is not spelled out for you, but you have to identify it. So in those cases, we have to know how to implement a specific pattern into a program. This is the idea behind Magic Square. I can just show you the program also. This is a program for, so this is the Magic Square program. I think you are shown in the class, so I'm not going into the details of why it works. Basically, if you see here, this is a website where they have explained how to create magic squares, right? So it's basically a magic square. 1 plus 15 is 16, plus 14 is 30, 34. And then if you add this up, this should also be 34. 8, 9, 13 plus 12 is 25, 25 plus 9 is 34. So like that you are adding up, right? So this is basically a magic square. And if you want to create a magic square, they have explained how to do it, how to create a magic square of odd order, right? So essentially here you have placed 1 somewhere. So here they are placing it in the first number in the middle column of the first row, and then going down and placing 2 in the other column, 3 in the other column, and then it goes in a sequence, 4, 5, like that, right? So then finally what you get is a magic square of order 3. So this is how you get it. And in the beginning, you can always calculate what will be the sum based on n square. Forgot the number. Yeah, n into n square plus 1 by 2. So for 3, it will be 3 into 10, which is 30, and 30 by 2 is 15. So for 3, all the diagonal column row should add up to 15. So let's check if that is actually true in this case. So 8 plus 6 is 14, plus 1 is 15. 8 plus 4 is 12, plus 3 is 15. 6 plus 2 is 8, plus 7 is 15. 4 plus 6 is 10, plus 5 is 15. Again, this is also 15. 1 plus 9 plus 5 is 15. 3 plus 5 is 8, plus 7 is 15. 4 plus 2, 6 plus 9 is also 15. And then the diagonals, if we check, 13 plus 2 is 15. 11, sorry, 9 plus 6 is also 15. So all 9 options, I mean the 3 rows, 3 columns, 8 options, 8 options will give you 15. So you can kind of like understand why this works, right? If I put 1 here, I should put 2 somewhere else, because if 2 small numbers are together, then it is a problem. I should have 1 along with some big numbers and 2 with some slightly smaller numbers. So everything balances out, and finally I get a sum that works. So that is what this process kind of guarantees. And how do I now put this in a program, right? That is the question that comes up. So the way that you do it is here. You can see again, this is for an odd magic square. There are algorithms for even magic squares, and I highly encourage that you guys please go and check it out. Okay, so this is n is equal to 3 magic square. So here this is basically you're initializing the magic square with a numpy array. So in case anyone doesn't know, numpy is a Python library where you have a lot of numerical functions functions and array functions. So arrays are basically collections of numbers, just like matrices are. And in NumPy, you can define matrices using arrays. So like this is how you do it. So you can see like if this function called zeros, it basically initializes your metrics to fully have zeros, right? So if you see this example, for example, here. This like, can you see this? One second. So if I give np dot zeros, it gives an array of 5 zeros. Actually, I'll show you in the terminals if I think it's. So if I go to Python, so whenever you want to use a library in Python or a module in Python, you have to first import it. Okay, so I have imported NumPy using this NP. NP means whenever I say NP, it's NumPy. So now if I give NumPy of zeros of 5, oh sorry, I spelled it wrong. Yeah, so you can see that 5 zeros in a 1D array, right? But also I can give 5 comma 2. Sorry, what is the thing? I have to give like this. Yeah, so you can see that now I have a 5 by 2 matrix. So in case that's not, sorry, exit and then clear. Okay, I'll just show you again because that was a bit chaotic. You can see a 5 by 3 array. Similarly, there's another function which is ones. So yeah, this just generates a matrix of ones. I think you have a function called random also. I don't know if it's called that or no, it's not random. I forgot. I forgot the command, but there is a way to generate a random matrix, or I think it's just by putting rand inside. I'm not sure. Okay, but point is that there are many ways in which you can generate matrices in NumPy. And NumPy is very useful because it's used for arithmetic calculations of arrays. So matrices are nothing but collections of numbers, right? Arrays is what we call it in computer science, but in mathematics it's called matrices. So when we want to do matrix operations or matrix manipulation, usually people use NumPy arrays to do that. Okay, so this is a point. So here we are just initializing the array to have fully zeros with the integer data type. So if I change the zeros to ones, will anything change in the program? You can answer in the chat. Can you understand my question? If I change the zeros, which is given here, which initializes it to zeros, if I change it to ones. So again, just to remind you, this is what zeros does. If I give some, suppose 2 comma 3, this is what zeros does. And this is what ones does, right? So if I now change this zeros, this line, if I change the zeros to ones, will anything change in the program? I'll show you the program. No. Okay, someone says no. Other people, at least one more person answer, so I know you're listening. Okay, yeah. Okay. One more person has said no. So yeah, you can understand, right, that nothing will change if I change this program to ones, and I'll show you why. Because this is just an initialization. Anyway, it's going to get overwritten when we actually construct the magic square, right? I'm going to put 1 to 9 in case of the 3 by 3. Let me just write this. Yeah, so when I write a 3 by 3 matrix is anyway going to get overwritten. So this is just so that Python knows that I have to not consider this 1 by 1 as a line. I have to consider it as a box, because by default it will consider it to be 1, 2, 3, 4, 5. I should consider it as a box. So that's why, I mean, as a metric. So that's why you have to initialize it in some way. Can be with zeros or ones or something like that. Okay. So here you can see that you start off with n is equal to 1, because we have to eventually fill in the numbers from 1 to 9, because it's a 3 by 3 magic square. And then as it was shown in this web page, you start by putting it in the middle, which is 0 and n by 2. This is the array indices. So 0 means the first row, n by 2 means the middle column, right? First you put 1 there, then you from 1 it becomes 2, then you move 2 to another like how they moved it here, like that you're taking the modern and going to a new place. And if that place already has a number, right, if already some number is occupied there, then it won't overwrite it, it'll go to the next position and then only it will write there. So here this is basically to prevent overwrite. Okay, so then you keep on doing it until you reach 1 to 9. So if I now run this program, you can see that it constructed magic square and it constructed the same magic square that we saw in this web page also. Okay, maybe I'll just put this web page in the PowerPoint. I know you guys did this in your thing, but in case someone wants to refer, it's here in this website. Okay, so yeah, so now if I give, for example, if I give this as n is equal to 5, then you can see that some other bigger magic square is done from 1 to 25, right? So this is the idea behind the magic square program, and this is for odd numbers. Now if it's an even number, it's slightly different, because in odd number we can identify which is the central position. So for even number you have to take a slightly different approach. I encourage all of you to try coding it up yourself and see if you are getting the correct results. Okay, so yeah, that is about the magic square program. Oh, sorry. Any doubts up till this point? I think you have already seen. I just wanted to give a recap of it in case people had doubts. You can ask now.
Ma'am,
Yeah, please go ahead.
here basically we are putting zeros or ones. No, can we take user input in NumPy?
Yeah. Why? Okay. You tell me, why will we take user input?
So basically, user gives a matrix so that I can find a saddle point, something like that.
But what? Okay. What is the goal of this program? You tell me that.
So basically, user gives a matrix, a 3 by 3 matrix, and I need to find whether it is having a saddle point or not.
But that is not magic square, right? That is a different thing. What is saddle? Sorry, I don't know the terminology. What is saddle point?
Like checking if the element is minimum in a row and maximum in a column.
So that is a different program, right? Completely. Here we are trying to generate a magic square.
Okay.
Correct?
Yes.
See, if I ask you to add two numbers and then you give me the multiplication, you have solved a problem, but you have not solved the problem which I asked you, right?
Yes.
There are
Yes, ma'am.
many problems and many programs you can imagine. Okay, that is a good program, that you have to find the minimum in a row or in a full matrix. For that you can get a user input, that makes sense. But right now we are discussing about magic square, right? So in magic square it doesn't make sense to get user input. What will you get as user input if you have a magic square program? You will get this number n, right? I have given it in the program, but you can actually get it as user input. That is one option, right? So that whatever number the user tells you, you generate the magic square for that order. But then it doesn't make sense to get the numpy input for a whole matrix, because the goal of the program is to generate the matrix. So you understand, you are answering a question which is different from the question we're talking about. So your answer is not wrong, it's just for a different question. Do you get what I'm saying?
Yes. Yes, ma'am.
Okay, cool. So that is, yeah, you can get a NumPy input, or you can even do it like how we used to do list inputs, right? We used to get it in 1, 2, 3, like in that. Anyway, you can do it. The documentation. So this is something that I would encourage all of you to do, is that every Python library will have a page like this. This is called the documentation page. Okay. So there are so many libraries and you can't remember all the functions in the library, right? So what you do is you can just search the documentation to see if there are any such functions. So here you have input output. So gen from text is used to read numbers from a file. Okay, suppose you have a text file, then from that you can input the numbers. Here input output, So these are like loading from files, saving from files. I think there is no way to get input from a user using NumPy itself. Maybe you have to use it as a list and then convert it into array or something like that. I may be wrong, because again, like there may be some other option. I'm just looking. So yeah, this is just, I'm just showing you guys, this is the NumPy library. So you can see that there are so many functions are here. So array to string, something, something, logic functions. So whenever you are stuck in something, always go and refer, okay? Because you won't have to remember that way. So even you can see that when I use BSC, if I hover over the function, it will give me the full description of the function along with the examples also. Similarly, here also, if I take, for example, some array operation, let's see, let's take array creation. Suppose I take array creation, you can see that, these are all the ways. So this is zeros, which we were talking about, right? So in this zeros, you can see that how it works, and with some examples and all. There's also a way to initialize an empty array. So even without having any entries in it, you can initialize just an empty array. Like that, you can also initialize once, full. There are many different ways. So yeah, I hope that answers your question. I went in a tangent, but I hope that clears it up. Any other questions? By the way, like having this kind of thing where I went to the documentation, was checking the function, always have that as a practice. Practically, we cannot remember all the functions and all the features, right? So it's always good to have like NumPy. Later, you might use pandas or matplotlib, depending on what you use for. So these things have very well documented pages. So please go and read. So is there any other question? I think you all did the Magic Square program in the class also. So it should not be very difficult. Okay, I think there are no other questions. Please feel free to interrupt in between if you have any questions also. So I think we can move on to doing some of the assignment problems of this week. So as usual, please answer in the chat. I'll give you some time to answer in the chat. So A, B, C, or D. Okay. So let me just open the chat in my phone so that I can monitor it as well. Okay. So this is the first question. Select the correct statements regarding magic square. So here there are multiple statements which are correct. So please try to select the correct statements for this particular. Actually, I don't know if I'm okay. I can see someone says A, C, and D. Others, only one person has answered in the chat so far. Okay, someone else says AC, someone says A and B. Okay, one more person says A and B. Okay, I'll give you 2 more minutes in case people still want some time to answer. Okay, ABC, someone says we can go to the answer. I can see there's some other issue in the chat. Uh, let's just come back to that. First, let's go to the answer. So I can see many people have given a lot of permutations of the options. So the answer is actually A and C. Okay, we can check if the 7 uh, one is correct. I don't know if it is. So the 7, this number is wrong. And I think this is also not right. So that's why the answer is A and C. Okay, so please check for this. So in between, someone had given a question about I'm trying to execute the magic square program taught in the NPTEL video lectures. It's sometimes showing index out of range error and sometimes doesn't show anything even though the program is correct. Okay. Can you okay, can you do one thing? Can you share your screen? Will you be able to share your screen so I can look at the program? I got the Magic Square program, like I got it from somewhere else or I wrote. I don't know if it is the same program which is shown in the NPTEL video lectures. So can you share your screen, whoever is having this issue? Please check if you are able to share your screen, maybe. I can stop sharing. No, ma'am, it's a different program. So then can you just share your screen or so that we can see what is the program like? We can maybe try to understand together where the error is coming. Does anyone else also face the same error? Have anyone else tried with this program that Himanshu was talking about in the chat? Okay, you try to find it. Okay, then fine. So then maybe towards the end of the class, just remind me after doing these problems, we'll try to look at your program once. I'll just go to the next problems and then after the problems, we'll try to look at your program. In meantime, if anyone else has faced similar issue and solved it, please help out Himanshu. Okay, cool. Okay, I'm sharing my screen again. Okay, so this is the question. So now next is this question. So for which matrices does the following code return true? I guess this is, yeah, just look at the code and what it's trying to do. And for which of these inputs does the code return true? Again, this can be multiple of them. So yeah, let me check the chat. Are there any answers in this? Try understanding what this program is doing, right? It does something for sure. So they have set expected to some of the metrics, the first row of the metrics, and then they are checking something with that expected value. So which of these matrices should give the same thing? I'll give you some time to answer. Please check. I don't see any answers in the chat. Are you guys here? Are you still here? Are you trying, or is it difficult to understand or something?
I cannot understand, ma'am.
Okay, fine. Anyone else who wants to try, or should I go to the solution? I don't see even one person to try A, B, C, D, or whatever these matrices, first, second, third, fourth, which will be the true. Okay, maybe I'll go to the solution because, but you guys are not saying anything. It's very difficult if you guys will just keep quiet. Okay. All of them is what one of you have said, all of them. Okay, good. So someone has tried the program. So, okay, so those of you who didn't understand, our point is that we have to go through this program and see which is the one which returns the. Okay. Okay, someone else has also answered. Good. So the point is that we have to first understand what is this program doing. Then only we'll know which of these satisfies the program, right? So first of all, you can see that we are defining a length of matrix, which is R is basically length of the matrix. And, if R is not equal to 0, or if R is 0 or it's not the length of the matrix, then yeah, if the rows and the columns are different, it's returning false. So basically, we want a square matrix, right? So first, let's check if all of them are square matrices. They are all square matrices. So this is definitely return. Okay. So that was the first condition itself, right? Now it's taking sum of matrix of 0, which means the sum of the first row, right? So now you take the sum of the first row. Let's see, is it first row or first column? I'm not sure. So let's try to understand if it's first row or first column, right? So let's take a matrix. What is the format? I forgot. Yeah. Or we can take NP. Okay. Just empty. Ah, that's what I. Oh, okay, okay. I forgot to give the. So let's try to give. Okay, so this is an array. Now, if I give the zeroth of this, it just gives me the first row. So whenever I give 0 of a matrix, it gives me the first row. If I give 1, it gives me the second row. If I give like this, it gives me the first column, 1 and 3. If I give like this, it gives me the second column. Okay, can everyone understand this? I'm extracting first row, second row, first column, second column from the matrix. Can everyone understand? If you keep quiet, I will take it as you have all understood. Okay, so I'm going to go. Do you guys understand what I did in these commands? Okay, good. So what does this do? Expected basically takes the sum of the row, right? So then in this case, it will be 8 plus 6 plus 1, 15. Okay. Now, for every row in the matrix, that means 0, 1, 2, right? If the sum of row is not what is expected, so we know that this is 14. So now I have to check 3 plus 5 plus 7, right? And 4 plus 9 plus 2. Are they also? Am I here? The connection dipped for a second. I hope I am still here. Okay. So here first
Yes.
there are three if statements, right? Let's understand them one by one. So first of all, we have expected, which is the sum of the first row. First, we are going to compare the sum of each row with expected. So we know that the sum of the first row is 15. Now it will check if sum of second row is also 15, sum of third row is also 15. Okay, if any of them are different, it returns false. Then it checks if the sum of so I comma j, here j in range r. So here it is checking the sum of the columns, right? It's keeping it's keeping I constant and changing j. So it'll be checking this column, this column, this column with what? The sum of the first row. And finally, it's checking the sum of the diagonal elements. So try to find out why this is the diagonal element, because this will be what is a this will be 0 and 0, this will be 1 and 1, and this will be 2 and 2. So we have to check whether those are also returned. Okay. So basically what it is telling is, if any of the rows, columns, or diagonals are different from the sum of the first row, it will return false. But what is that kind of matrix called, where all the rows, columns, and diagonals give the same sum? That is nothing but a magic square, right? So this program is basically to check for magic square only. So what do we have to do find out these options? We have to check each of them whether they are all magic squares or not. Okay. Does everyone understand the program now?
Yes, ma'am.
So first of all, it checked if it's a square matrix, because magic square has to be square. Then it checked with each row, it checked with each column, and it checked with each diagonal. Okay, so that is what has happened in this program. So now if I go to the answer, those people who worked it out were right. All of the above matrices are actually magic squares. So you can please try it out on yourself also. A fun thing to do will be that you can write some similar program. You can generate magic square and then try to feed it into this program and see if the checking is done properly. Then two ways you can check. You can check your first program and second program also. Okay. Okay. Next question. Suppose you want to simulate the birthday paradox. Again, I hope that you all know what is the birthday paradox. It is that, it's very common for you to have same birthday as someone. That is the simple way of saying it. But yeah, basically you want to simulate the birthday paradox by generating some random birthdays for a group of people. In which case, which library function will you use to create random integers to represent birthdays? So that I can suppose I map the numbers like 1 is January 1st, 365 is December 31st, 23 will be January 23rd, something like that, so that I can assign a number to each person. So what should I use? Okay, I see that people are answering. Good. But they are answering A, random dot rand int. Other people, I see 3 answers in the chat. Others also, please try to answer. Okay, one more person says A. I'll give you one more minute maybe if people. Okay. Okay. I see many of you are saying A. And sorry, you're all right. The answer is A. So we need a random integer, and that's what this does. So again, if you want to know what it does, if I okay, what I don't know the okay. So you have to give the first and second number. Okay, let's try it now. Yeah, okay. So that's how it works. Fine. So again, every library, like if you give random documentation, Python, you will find that Yeah, so this is the random generator. You can find all the different functions that are there. So again, it's very good practice. Like I use matplotlib a lot to plot things, my results when I do research. So I always have the matplotlib library bookmarked because it's difficult for me to remember which function is for me to change the color of the line or those kinds of things. So it's easy for me to have it in the bookmarks. So that's just a practice for coding practically. Okay, good. So which of the following are functions in the date time module of Python? There are multiple answers which are correct. So date time module, again, random is one which is used for generating random numbers. NumPy is used for array manipulation. Date time, as you can guess, is used for dealing with calendar dates, right? So please check out which one should be the correct one. Correct options actually. Okay, A and C, A and B. Anyone else? A and B. So why don't you guys try looking at the date time documentation and see the answer? That can give you a good idea of how to use the documentation also. Okay, A and B. I'll give 1 more minute in case of other answers. Okay, I don't see any other answers. We can go to the solution. The solution is actually A and C. Okay, and we can, these are not really functions and we can check that. As I said, let's go to module documentation. So you can see here, and you can see that here you will have all the functions which are possible in this. So these are all the different functions. Okay, go to date time dot date time. We have date time dot now. That's a function which returns date time dot now basically returns the current date and time. If there's date time dot present, let's check. There's no such thing. So that is not a real function, right? Similarly, if I give date dot today, you can see that there is such a function that returns the current date. But if I give date dot now, there is no such function. So again, this shows you, like, because all these kind of, it's difficult for us to remember which is the correct way or which is the correct name of the function. But when we use the documentation properly, if you know how to use, then you can very quickly check what is the format. Okay. I hope there are no questions in this. This is not a, this is a straightforward question. Okay, so let's go to the next question. So this is a little long question to read, but the answer is very simple. So let me tell you what is this. Basically, this is a question which describes a game called Masked Gun. Okay, it's a simple guessing game where player attempts to unlock a masked gun by correctly guessing a secret 4-digit code. So it's like a password. You have to guess a password basically. So here you have a guess set of steps which actually tell you how do you actually do this program, but the steps are not in order. Okay, they are in some different order. So you have to give the answer as a sequence of numbers. Suppose the correct option is that first 5 should come, then step 2, then step 1, then 3, 4, 6, then that will be your answer. That's not the answer, I just said some random numbers. Okay, so read the all the steps and order them basically of to how to do this program. Okay, this will take you some time to read and understand. So I'll give you 5 minutes to read the question and try to give the solution. So here the answer is not going to be A, B, C, D. It's going to be some sequence of numbers like 3, 1, 5, whatever, something like that. Do you all understand the question?
Yes, ma'am.
Okay. Okay, good. So please try out the question. Okay, someone has given an answer 213456. Others also, please. I need at least few people to answer and then we'll look at the solution. One, 3, 6, 2, 4, 5. Hmm. Okay, I think the last Last two steps, both of you agree, but first few steps you don't. So at least few more people try, because then we can go to the solution. Yeah, I'll give you a few more minutes. Others, I hope you're trying. I need at least few more people to answer so that we can go to the solution. Okay, 316245. Three two six one four five. Okay. I see that people are answering. Maybe we can go to the solution so that we can get to the programs also. So solution which is given is 321645. I don't know if any of you gave it. Okay, someone else has given something else. Essentially, first they say that first you generate the secret code, then you display the masked gun, which doesn't really do anything for the code. You set up the loop, you compare, then provide feedback and end the game. So I think this 1645 is definitely has to go in sequence. You have to generate the code in the beginning, because what else will you compare it to, right? You have to generate the code before you do the loop. Otherwise, how will you what will you be comparing to? I think displaying you can, yeah, you can do it after generating the code or before the code, but that I don't know if it has much to do with the functionality of the program. Point is that 3 has to be first, and then 146, sorry, 1645 should be in the sequence, because first you generate a code, then you set up a loop so that you can compare, right? So every time you're going to compare, you're going to provide feedback so that people know that if all four numbers are wrong, if two numbers are correct, one number is wrong, then finally end it when the player guesses the codes or runs out of attempts. So this is how it works. I think 2 is not very important according to me. So it could have been 231645 or 321645 is not an issue. Does everyone understand? I think the position of 2 does not matter that much, but please check that 31645, this sequence is in the correct order. You cannot compare before setting up the loop, right? So that's why 6 should always come after 1. Similarly, you can't give feedback before comparing. So 4 should always come after 6. Okay. Does everyone understand the answer? Okay, I don't see any doubts or questions. So I'm going to go to the next question. Okay. If you have any doubts, please stop me. Okay. To implement a magic square, we use a concept of matrices. Select the statements which are true in this context. Okay. So, yeah, again, there could be one or multiple answers here. So be careful. Okay, someone says A. Okay, I see a lot of you saying A and B. Can go to the answer. The answer is actually A. It should also be B. I'm sorry. B is also correct. I don't know why. Yeah, A and B is the correct answer. Okay, fine. Okay, so this is the next question because NumPy, okay, just to explain, NumPy can also be used for implementing matrices as we explained. Okay. So this question I don't think you can do now, but I'm including it because later I want you guys to try and I'll tell you how to do it when we get to the program section. In essentially they have given you a list of 60 people whose birthdays fall in different dates in the year 2000, and you have to run a code using this given data to check who and all birthdays fall exactly on a Tuesday. So it's not very easy to parse this right now, so I'm not going to make you do it now right now. The solution is there in the slides. So the point of this is not to count look up in a calendar which and all are Tuesday and then get the answer correctly, right? The point is to write a Python code that can do that. Okay, so I'll show you later how to find out the day of the week from a given date. So maybe I'll just show you for one date, but try to write a program that can accept these dates and or look at these dates and tell you how many such Tuesday people are there whose birthday falls on a Tuesday. Okay, I'm including this in the slides because as I said before, all slides are available to you. What is expected is that you will later, when you have more time, I don't want to reduce the time of the class. When you have more time, go and write a program and check if it gives you the same answer that is displayed on the screen. Okay. So that is about this question. Let's go to the next question. Okay, very nice. So this is also a question where you have to look at a program and find out what will be the predict the output of that program. Okay. So here basically this is the program on the right hand side. So here if P is 1 2 3, Q is 4 5 6, then P plus Q is the list 1 2 3 4 5 6. This is basically concatenation and this is called slicing. Slicing means selecting only certain elements from a particular list. So this is basically, it uses slicing and concatenation. And what you have to do is for this given output 90, 47, 8, 18, 10, 7, you have to find out what will be the solution that will come. Okay. So please try it out right now, you guys. Try to understand what is this program trying to achieve and then give the solution which matches. Okay.
Hello.
Hello? Is there a question? Okay, I don't see any options yet. Hope you guys are working it out. I'll give you a few more minutes. You know, instead of, you can first try to, as I said before, when you try to do programming, you can always break down the problem into a simpler case. So maybe you can try doing it, just with two elements and see what this does for a list which has two elements. Then we can check what happens to a list with three elements, right? So you can try that out. Okay, one person says D. Others? Okay, one more D. I'll give you maybe one, 2 more minutes and then I'll show you the solution. If people are still working it out. Okay, one person has said C. Maybe we can go to the solution. Others keep trying and I'll just explain in the meantime. The answer is actually C. So, do you understand by looking at C what this program is actually doing? This program is actually arranging the elements in ascending order, right? So people who said D, you had the right idea, but you went in the wrong direction. This is a descending order. This is actually arranging the elements in an ascending order. 7, 8, 10, 18, 47, 90. You can see the elements are increasing. So let's try to understand what's happening, right? We have a list which is given, which has 6 elements, and we take S to be the first element, which is 90. Okay, let's imagine that L only has 90 and 47 to make our life easy, right? So now S will be 90. Okay, so everyone keeping track, L is 90 and 47, S is 90. Then what it does is it goes from okay, let's take 3 elements because I think just having 90 and 47 will not work. So like 90, 47 and 8 and S is 90. Okay. Let's say I in range of 1 to length of L. So till 1, from 1 it goes to length of L is 3, but then it will only go for 1, right? Okay. So that's what is going to happen. 1 and 2. It will consider 1 and 2. Okay. So now it will set some flag to true. Now within this loop where it's going from 1, first it's 1, then it will go to 2, but when it's 1, there is a nested loop. There's another loop within the loop which is going through S. Okay. So it goes for the range of length of S. So we know that S only has one element. So right now it is, just going to be just one time. So here it checks now if L of I, which means that 47 is less than S of J, right, which is 90. And then if it is less, then what happens? Then you order it such that the smaller element comes first and then the bigger element. So that is what this thing is doing, right? It's taking all the elements which are before index J, then the list with only one element, then elements starting from index J and adding them all together. So essentially it will take 47, then 90 and 8. Okay. Then again it will compare with 8. It will find 8 is even smaller. Then it will be like 8, 47 and 90. So this is what is happening. And every time it finds that something is not in the correct position, that something is still lesser but in a higher position, then this loop keeps running. If all the things are ordered, then this loop itself will not run. It will just append all the correct things and it will print the correct string. Okay, this is what is happening. You can try running this program on yourself and see if this is the correct interpretation or not later. Okay, does everyone understand? Basically this loop keeps running until there is some element, suppose 8. See, I goes from 1 to n, so that means it goes from the second element till the end of the loop, right? And it keeps checking if first element is bigger, second element is bigger, sorry, not bigger, first element is smaller, second element is smaller, third element is smaller. If it is smaller, it rearranges it so that the bigger elements are always at the end and the smaller elements are at the beginning, and that's what this option shows. Does everyone understand? Any doubts in this question? Okay, I don't think so. We are actually kind of behind time. We have to do some programs also. So let me just go to the next question. If you have any questions, we'll address it at the later of the class. So what does this function do? Random.choice. Anyone knows? This is not a program. Okay, seconds are random, selects a random element from a sequence. Others? Okay, I see a lot of people saying B. Maybe for interest of time, I'll go to the solution for this one. It is actually B and you can try it out later. I'm going to the solution because we have to do at least 1 or 2 programs you have to do in the class. Okay, identify magic squares from the following. Let's skip this question. I hope you all know what are magic squares by now. Please try it out and find out if your answers match. Is that okay with everyone? I'm going to skip this question so we can go to the programs because we only have half an hour left. Okay. Okay, these are the answers. Please just look at it in. So I'm going to give you some time. I have, I think, 5 programs. We won't be able to do 5. As usual, I'll share all the solutions with you, but let's try to do 1 or 2 programs in the class itself. So I'll give you some time to do the program. Okay. This is the first program. Accept 2 square matrices A and B of dimensions n cross n, which means both are same. So they are square matrices as input and compute their product AB. Okay, so first line of the input will have the integer n. Then you will have the first matrix A, which will be n lines, then second matrix B, which is n lines, then your output will be a sequence of n lines, which is the row of the matrix AB. In case any of you don't know, matrix multiplication is not just normal multiplication. Yeah, so you have to, this is how matrix multiplication works. I think you all know. First row is multiplied by the elements of first column, and then each element by element you have to multiply and add them together. So 1 into 10, 2 into 20, 3 into 30 you have to add, then 1 into 11, 2 into 21, 3 into 31 you have to add. Like that you have to do. So this is how you will get the solution. So yeah, if you don't know about matrix multiplication, might be a little difficult, but I think all of you should know. This is mathematics, not computer science. So once you know that, try to implement this. So I'm saying that it's not as simple as A into B, right? You have to extract the first row, first column, and add and multiply in such a way that it is correct. Okay. So I'll give you 10-15 minutes to try this out. Please try it out and try to get a solution using some loops and all. I know I'm sure there are built-in functions to do this, but try to do it manually by extracting the elements. That'll give you an idea about how to deal with arrays in a better way. Okay. I'll give you 10-15 minutes. Please try it. Also, the person who was having issues with the magic square thing, we can see it later if we have time. Otherwise, you mail me and I will look at it in my own time and give you a mail back. Okay, I think it was Himanshu. You were having some issue with the magic square program. Let's see if I have some time at the end, I'll look at it. Otherwise, you mail me the program and I will look at it in my own time. Okay. Okay. Okay, great. So I'll give you 10 minutes, 10-15 minutes. Please try it out. Once you get your question, please please try to find it for these two matrices, 1357 and 2468. Your solution should be 20, 28, 52, 76. Yeah, sure. Sorry, here you can have the problems. Are you guys able to do it? I hope you are trying. I'll give you maybe 5 more minutes until 7:35, and then, or maybe I'll give you till 7:35, and then you can show the solution. So remember, the row of everything has to be added with a corresponding column element, and you have to add them. That's how matrix multiplication works. Okay, someone has given the solution in the chat. Please try it out with some, it's working. That's great, fantastic. Others also, please try it out. If you find any difficulty, then maybe I can also give the solution. Others, please keep trying, but I'll also show the solution side by side. Unless someone is trying and doesn't want me to share, I'll just share the solution. Okay. Others, keep trying. As I said before, you should always try to do a program on your own first before you. So this is week 1, program 1. Okay, let's close this for now. Okay. I hope you can all see my screen. Okay. Let's just I just share you. So this is basically how you're accepting your matrix A. This basically we are using lists right now. You can also use NumPy. But as I said, I don't think there's a way to input using NumPy. I checked the documentation very quickly. I could be wrong. There are many functions and I could have overlooked. But this is how you accept using a list. This is how you accept. Then you're initializing your matrix C to be a zero matrix. So you can see that first of all, you have I in some range, and within I you have a row, and then in each I you have another row. Similarly, C, you are having a row which you are initializing to be 0. So this is basically what our np.zeros does, but we have done it explicitly, that's all. So as I said, for a matrix product, this is the formula, right? You take the ith row and the you take the kth row and the kth column, kth row of the first matrix, kth column of the second matrix, and you have to kind of multiply them together and add to each one. So you can see there's a plus equal to, so it keeps adding. Okay, so this is how you basically do it. And if basically you keep printing it, you can see that if j reaches the end of the row, it ends the line and goes to the next line. Otherwise it keeps printing in the same line, because once it reaches third element, it should actually print in the next line. So that's why there is this end statement, right? So let's try doing this now. Okay, or actually, okay, clear. So I'm going to run the program as given in the program statement. The first line of the input should have integer n. Then you have to give two n lines where the first matrix comes, then the second matrix. So I already calculated for 1357 and 2468. The solution should be something like this. So let's see if the program is able to do it, right? Okay, 1 second. There is some power issue here. Give me a second. Sorry, can you hear me? My tube light stopped working for some reason. Sorry. I don't know what happened. I'll have to see it later. Anyway, what I was saying was, what was I saying? Yeah, so this is basically, we are running the program. So I said we'll put 2, then we'll put 1, 3. How are we supposed to enter? 5, 7. Why is it not running? Okay, okay. I think I understood. So we should give 4. It was running before. I don't know what's happening. Give me a second, guys. 1 sec. I don't know what's happened. Oh, I have to give comma separated. Okay, okay. I understood. I forgot. Okay. So you can see that the answer is 20, 28, 52, 76, and that's exactly what the calculator also told us, right? So this is basically, yeah, this is basically how it works. So here the issue was that I didn't use the comma before, which I forgot that it was comma. So that was why I had that issue. Okay, so everybody understood, right? If the basic program is very simple. These are all lots of lines are there for accepting. The basic program only comes here, right? We have to add the ith row with the multiply the ith row with the jth column, and then basically put it in here. Okay, that is what is happening. I hope everyone is clear with that. Any doubts in this? I think this is a simple enough program. Once you know matrix multiplication, and if you know how to identify the elements of a matrix, it's easy enough to implement. Okay. Okay, fine. So then let's go to the next program, which is this one. I hope no one has any doubts in this. This is the next program. Putting into full screen. It's another matrix program. Accept a square matrix A and an integer S as input, and print the matrix S dot A as output. So multiplying a matrix by an integer is equivalent to multiplying each element. So for example, if you multiply 2 with the matrix 1, 2, 3, 4, you will get 2, 4, 6, 8. So 2 into 1, 2 into 2, 2 into 3, 2 into 4. So the first line of input should be the positive integer, which denotes the dimension. Then each of the next n lines will be space separated integers. So yeah, be careful here. It was comma separated. Here it's space separated. Of course, when you do it, you can do whichever method you want. But when it's an exam situation or a course, we should adhere to whatever they are saying, right? So this is space separated integers, and the last line of the input should contain the integer s. You should print the matrix as output by like this. Okay. So this was one of the assignment problems from last year. That's why they have mentioned all of this now. So you might also be solving similar questions now. So please try it out and let me know when you are able to converge on solution. Okay. try with this example itself or some other example. You multiply by 100, for example. Try to do those questions. Okay. I'll give you 10 minutes to do this. I think it will be easy only, but I'll still give you 10 minutes. Please try it out. Okay, great. Ma'am, I've rectified the magic square program. It's working well for all inputs. That's great. So what was the issue? Do you know? Is it like dot product? Dot product is slightly different, right? Dot product means you will have two matrices and okay, I mean, I don't know. Dot product means you will have two vectors and you'll be multiplying element wise. This is more like scalar multiplication in the sense that you're just multiplying a constant with each of the terms. In dot product, it will be something like 1, 2 with 3, 4, and then you'll multiply 1 into 3 plus 2 into 4 or something, right? So I think so. If the vector dot product is what you mean, or scalar dot product, whatever it's called. And this can be taken as one type of multiplication. Anyway, it's good that you itself rectified the program. That's very good. To Himanshu. Okay, someone has given the solution. That's very good. Others also hope you're trying. I'll give you maybe 2 more minutes and then we'll go to the solution of this question. Okay. Good. Yeah, it's normal in programming that we will, make mistakes. But if you're able to identify, that's part of it. That's why it's important to know the logic and not simply copy someone's program. It's good that, debugging is as important as programming. Okay, I'll give maybe 2 more minutes and then we'll go to the solution. Okay, someone else has also given the question, sorry, the answer. So then maybe, yeah, so just be careful that you have used space as the splitting thing. Yes, you have, both of you have. Yeah, try it out with this question. And in the meantime, I think I can also show the solution. Good that you guys are doing it fast. Then we can go to more programs. So this is basically the program. Close all these other things. So yeah, this is also a simple program only where you are getting the matrix as input using space separated values in this case. Then you're inputting the scalar for multiplication, then multiplying each by s and you're printing it using the space as well. So these two can actually be in the same loop, but just to show the how to get the output separately, it's given separate. Okay, you can put this both in the same loop as well. So if I now put the run the program, so let's the example they gave, which is 1 space 2, 3 space 4. Okay, and 2. So then you get 2, 4, 6, 8. So it's the order of the matrix, which is 1, 2, 3, 4, multiplying by 2 to get 2, 4, 6, 8. Okay, this is a pretty simple program. Does anyone have any doubts in this program? Any questions in this program? So now you know how to multiply each element with a number, which means that tomorrow I ask you to divide each element with a number. You can do that easily. Add something, add a constant to each of the elements. You can do subtract a constant from each element. You can do. So yeah, that's the point, right? You figure out the logic. The logic is how do I go to each element in the matrix. After that, whatever function I want to do, I can, depending on my use, I can give whatever program I want to. I think no one has any doubt in this program, and I think so few of you have already solved it. Very good. So we'll go to the next program. Okay. So write a program to find the transpose of a matrix. Okay. So transpose is basically you interchange the rows and the columns. Suppose the input is a 2 by 3 matrix, is a 3 by 2 matrix where it's like 1, 2, then the second row is 3, 4, 5, 6. The output should be 1, 3, 5, 2, 4, 6. Okay, like 1, 3, 5, 2, 4, 6. Suppose you're given this matrix, the transpose will be this. Okay, try doing this. There is a numpy function which does this as well, but also you can try to find that from the documentation. Other than that, you can also try to do it yourself. I'll give you maybe 5-10 minutes for this. No, there are no input constraints here. You can try to take it as a nested list or something if you want. The previous questions I had copied from the previous year's assignment. That's why all those input constraints were there. So here I don't have any constraints. This is a program that's okay. Okay, great. Someone has given the solution. I can also show you the solution which I have. I did like using list comprehension. Yeah, as I said, if it works, it's always, working. So here, this is also using a similar kind of concept. I think what you did, but it's just given in a line. So I'm just going to the solution, everyone. Please look at the screen so that we can. So essentially here you can see this is the matrix 1, 2, 3, 4, 5, 6, and it can print it. Here basically, yeah, so here basically what was I doing? Why is it printing two? Okay, so okay, I understood now. I had given three methods. Okay, so the first method is this. Essentially, you can see that we are just have to you have to swap the indices, right? Row should become column and column should become row. So res is just what is storing the transpose. So res is just m, which is this matrix or this list of j of I. Instead of ij, you're going to do ji, and j is the uh, row number, sorry, the column number, and I is the list length of the row. So this is how you do it. This is just in one single line, and then you can do it. Other than that, as I said, in NumPy itself, you have this transpose function, which takes a matrix as input and gives you the output as the transpose of that. Apart from that, you can also use this np.array. If you give dot t to the array, that is only applicable for a numpy array. You cannot do dot t for a list. If you give it for a numpy array, then it will give you the transpose. So all three of these methods give you the same kind of solution. Okay. So we can, if you run this, actually I gave different matrices for each of them. I don't know why. Let me just copy this. Yeah, okay. Now if I run this, you can see that all of these give me the same solution: 135246, 135246. Okay, so this is the idea. This is, again, the reason I put three methods is to just show you. So instead of writing the code, even though the code is one line, we already have NumPy is able to do it in two different ways. Okay, so here range length of m will give you how many of the rows are there, and length of m of 0 will give you the number of columns. Okay, so that's why you have to do it in the opposite way. Does anyone have any doubts in this program? This is a simple program again. Any doubts? If not, let's try to do one more program because we have 10 minutes. Let's try to do one more program before we end. And then the fifth program you guys can see on your own. That the fifth program that I have included here is basically to extract the day of the week from a date. And as I said before, there was also an assignment program which told you to do the same thing, to extract number of Tuesdays, right? So this is basically to do the same thing. Okay, so basically try to look at this function and yeah look at that program and try to put it for that previous program assignment question which I said. Yeah, NumPy is having a function called transpose. So I'll go to VSC again. You can see here transpose is a function inside NumPy, and if you give np.array and then if you give np.transpose, it automatically gives you the transpose. Again, if you go to the documentation of NumPy, I had it here somewhere. Can find it, right? Returns an array with the access transpose. So yeah, that's what I said. Already, whatever functions you think of will mostly 99% we already part of some Python library or the other. But it's always good to also do it without the library, like how your friend and how I showed in the first method, how you can hard code it, right? Because if you understand the logic, then it's always good to have it, right? Otherwise, we have to remember set of libraries, look up in the documentation. But if you understand how to do it, even you can write your own code for it. Okay. But usually the built-in codes, the advantage of using built-in code is it will usually be more efficient. When we write a code, it will not be as efficient as a built-in code. So it doesn't matter for 2 by 2 matrices, but maybe for a 100 by 100 matrix, the NumPy method will be much faster than the normal method. I don't know, I'm just saying. So these are the things that you have to think about, right? Now we are only learning programming, so it's not a problem. But practically, when we do programming as your job or as part of your job, you also think about things like computational cost. How much time is this program taking to run? If the program is taking very long time to run, that's also a problem. Okay, this is the idea. So let's try one last program, or maybe we can end, or do you guys want to do one last program? Anyway, I will share all the slides and programs with you. Maybe I'll just show you the question and the solution quickly. Huh. So this is another program where you have a given a binary matrix whose elements are only 0 and 1. We need to print the rows which are duplicates of the rows that are already present in the matrix. So for example, if you give this as the input, you can see that in row number 4, 110101 is already a duplicate of 110101, the first row. Similarly, 001001 is a duplicate of the second row, right? 001001, and even the sixth row is a duplicate of the second row. So you have to write a program for this. I'll give you some 10 minutes to do this and we can end here. Okay. Did everyone understand the question? Yes. Okay. Great. Try this question and then we can end with this question. I'll give you time till 8 and then I'll show you the solution and then we can end the class. Okay, I think we can go to the solution and finish the class. Those who are trying, please keep trying, and I'll just show the solution, but please try to do it on your own as well. So this is the solution. So basically, this is we are checking duplicate rows for a matrix and the rows and the columns. So basically, you will be running the matrix with the rows and the columns and comparing with each of them. Okay. So essentially, you can see that for I in range of rows. So first you're looping through all the rows, then checking whether or not the row is repeated. So if the row is repeated, this now found will become true, and then you will understand that there is a loop, there is a duplicate row. So first you loop through all the rows before the current row, sorry, row. Then check if any of the matrix elements are different. We know that it's not a duplicate, right? So then you can go to the next one. So if all the elements are the same, then you have found something and you can print the row position. So this is a basic idea. You're looping through all the rows, and then in each row you're checking. Okay, I think some internet issue. But yeah, in each row, you're checking element by element, any of them are equal or not. And if they are equal, then if all the elements are the same, if any of them are not equal, then we can stop looking, right? Only one element has to be different. But if all of them are equal, if you reach the end of the row, that is, you have reached the last column, and still all of them are same, then you can mention it as repeated and print it. So if I run it for this matrix, you can see that just like how it showed, there's a duplicate row at position 4, 5, and 6. Okay, I know I went little fast in this, but it's because it's already time. But basically, I will be sharing as usual all the slides, programs, and everything. So please try it on your own. Try doing all these programs, and then it will be really easy for you to understand logic. And as I said, programming is all about pattern recognition. So try to see if you can really identify the patterns and the logic that is being used in all the programs. Okay, so I'll just share this link in the chat because this is my website where I maintain all the links. So you can see here that I have the YouTube playlist of all the videos till now, and we also have the slides. And along with the slides, if you go to week 2, for example, you will also find all the programs that we were used in the class. So please look at all the programs, but don't just run it blindly. Try to write your own code and then only compare with the code whenever you're stuck. Okay. So that's all for today's class. I think we are ending on time. Any other questions or clarifications at this point? Otherwise, we can end for today. If not, we can end the class today. Okay. See you all. Have a nice rest of your week. Okay. We'll see next week. Same time for my class. In between, you will have the other PMRF sessions. Okay. Okay, guys. Bye, everyone. Good night.